Hello friends, this is the sixth session on numerical analysis of BSc 5th semester. In this session we shall discuss the error in the computation of numbers with positive exponent, that is number of the form x to the power n. So let us have a brief recap on the previous session. In the previous session we have discussed a couple of examples. We have solved a couple of examples on errors associated with the addition of numbers, subtraction of numbers and multiplication of two numbers. So with this background, now we shall move on to discuss the error associated with the computation of the number of the form x to the power n. So you have to be bit careful here. N is a positive rational number. So in any number with positive rational exponent that we are going to consider over here, and we are going to evaluate the error associated with that number, the error associated with the computation of the number of this kind. So let us begin the topic. Okay, now when n is a positive rational number, the relative error, this is very important. We are now speaking about the relative error ER. So the relative error in the computation of a number x to the power n, any number x with the positive rational power n, that is x to the power n. We are computing the number x to the power n, and now we are saying that the relative error associated with that computation is always less than n into modulus of ex divided by x. So here what is ex? What is ex? Ex is the numerator. Ex is the absolute error in the base number. So what is the base here? This is the base. X is the base. So the error associated with x, that absolute error associated with x, that is ex, that is to be taken in the numerator, divided by the number x itself, only the base, that we have to take in the denominator, and we have to multiply to that value with n. So that total answer is always greater than the relative error, or we can say that the relative error is less than that number. So this is the formula we will be using in the problems. So let us solve the examples on this topic. So the first example is here. What is the question? Find the number of trustworthy figures in the computation of the number. You please look at the number, how the number is. The number is 0.318 to the power 3. So here x is 0.318. This is x, this is x, and n is 3. N is the exponent. So that we have to take into account. We have to find the number of trustworthy figures in the value of this. If we see the answer of this with our calculator, the answer will be having many decimal places. We have to find out how many figures after the decimal point will be valid. That gives us the correct answer. That we have to find out. Assuming that 0.318 correct to last figure. We are making an assumption here that in this number 0.318 x, it is corrected through to last figure. Last figure is 3. So here we are considering the 3 decimal places. So up to the last figure if we consider, then what will be the number of trustworthy figures in this computation, that we have to find out. In order to do that, we have to determine the error associated with this computation. Now we have the formula. We have the formula from the previous slide we have seen. The absolute error in the number x to the first we will see, please see the formula here. What is the formula that we will see? The formula is here. The relative error in x to the power n is this thing. This is the formula. In this formula we want e to the power x, sorry, ex. Ex is the absolute error associated with the base number x, that we have to determine. So first I am doing that calculation. So here that evaluation is going on. First we are finding the absolute error in x. So absolute error in x we have discussed in third session. The absolute error in the number is always less than or equal to 1 by 2 into 10 to the power minus 3. I request you to please look at the discussion on valid significant digits. In that discussion we have stated that when the number of the number of trustworthy figures is n, then the absolute error is always less than or equal to 1 by 2 into 10 to the power of minus n. So 10 to the power of minus n, what it stands for? It stands for the unit of the last digit present in the number x. So here in the number x, what is the number x? X is here. In the number x, what is the last digit? The last digit is 8. What is its place? What is its unit? Its unit is 10 to the power minus 3. You can see this place is 10 to the power minus 1. This place is 10 to the power minus 2. This place is 10 to the power minus 3. So that we are taking over here. So what is the absolute error in x? Absolute error in this x should not exceed, or we can say that absolute error in x is always less than or equal to 1 by 2 into the unit of the last digit in x. The unit of the last digit in x is 10 to the power minus 3. Its place we have to write down. It is 1000th place, that is 10 to the power minus 3 unit it is having. So that we have to multiply over here. It is 0.5, 1 by 2 is 0.5 divided by 1000, that gives us 0.0005. That is the absolute error in x. Ex we have computed here. So this value of ex we will be using now in the formula of error in the number x to the power n. That is very important. So what is the error in the number x to the power n? It is here. The relative error in the number x to the power n is always given by n into modulus of ex divided by x. This is the formula which we have stated at the beginning. Now here n is the exponent. I have shown you in the previous slide. N is 3. This exponent n is 3. So we are writing n is 3 here, and modulus as it is. Ex value we have computed here in the previous step, that is 0.0005. The same thing we have written here, and the base x is the base number, that is 0.318, that we have written in the denominator. And if we simplify this using the scientific calculator, the answer will be 0.00472. So this is the relative error ER we have computed, but we want the absolute error. And we know the definition of relative error. Relative error is nothing but absolute error divided by x. Now the same thing, absolute error divided by the given number. The relative error in any number is absolute error in that number divided by that number itself. Now we are calculating the absolute error with the help of the relative error. Therefore absolute error is equal to relative error into the number itself, using the same definition with little adjustment. So this is the thing we are having here on right hand side. I hope you understood. Relative error is equal to absolute error divided by the number x to the power n. The number x to the power n has been transferred to the RHS. It has come to the numerator with ER. So the absolute error in x to the power n is ER into x to the power n. Now here we are having ER in our hand. Just now we have computed it. Let us substitute into x to the power n is the given number, that is 0.318 to the power n. We have written it. So here it is very simple to calculate this using the calculator. So if you calculate this x to the power n, this is x to the power n. If you calculate it, the answer is going to be 0.032157. So this is x to the power n. This is very important. This is x to the power n, that is 0.318 to the power 3. Now let us multiply these two. We will have the answer for absolute error in x to the power n. Absolute error in x to the power n is now computed as 0.000152. So by looking at this, when absolute error in x to the power n is 0.000, there is no variation. Absolute error is 0.0001. That is nothing but very small. It is starting with the fourth place. It is making the difference in the answer from the fourth place, because the absolute error is having the value 0.000152. That is nothing but it is affecting to the value of x to the power n from the fourth place, because this is contributing towards the value of x to the power n. So this error starts with the fourth decimal place. Therefore we say that the error affects the value of x to the power n from the fourth decimal place. Therefore, when the answer is affected only from the fourth decimal place, we can say that, hence we can say that the number of trustworthy figures in the given number is 3. When the number is affected, when the total answer is affected only from the fourth decimal place, we can say that the first three places are okay. The first three decimal places, the first three places will not be affected. So therefore, the number of trustworthy figures in the given number is 3. So therefore, what is the answer of 0.318 to the power 3? We have computed it using the calculator as 0.032157. Here in this number, only 3 decimal places will not be affected. Trustworthy figures is 3, that is 0.032. The fourth place onward, that will be affected. We will not consider them. We are considering only the trustworthy figures. Therefore 0.3032, that is the final answer for this question. So this is how one can solve the examples on this numbers of the form x to the power n. So this is one example I have shown you. You can try another example. It is here. You please look at this. Find the number of trustworthy figures in the number 653 to the power 1 by 4, where 653 is correct to 3 significant figures. Again 3 significant figures they have given. So here you should understand what are the given data. The given data, x is 653, that is the base number. You please observe. This is this base is to be taken as x, and exponent is 1 by 4, that is to be taken as n. And now absolute error in x, we have considered x here. X is 653, all the figures are significant, so 3 is the last figure, and we are now saying about what is the absolute error in x, that is ex we are now finding. Again you look at the discussion on valid significant digits, wherein we have explained about the absolute error in the number of the form x with n number of valid significant digits is always less than 1 by 2 into the unit of the last digit. You look at this number. What is the last digit? Unit of the last digit? This is units place, this is tens place, this is hundreds place. So the last digit is this digit. The digit is having the unit place, that is 10 to the power of 0 place. So that we have to multiply here with 1 by 2. So it is 0.5 into 1. This is 10 to the power 0 is 1. So error in ex is 0.5 that we are having in our hand. Now this value, let us substitute here in this formula. We are having the formula for relative error in the number x to the power n. In the number x to the power n, what is the relative error? It is given in the beginning of this session. It is given by this formula. So now we shall substitute n, we shall substitute ex, which is now computed, divided by x, the given base. Base number is 653. So n is 1 by 4. It is here. Modulus of ex, just now we have computed 1 by 2, that is here in the numerator, divided by x. X is the base number 653. So if we evaluate it, we will get the answer as 0.0002. This is the relative error in x to the power n. With the calculated relative error in x to the power n, we can compute the absolute error in x to the power n by using this formula. This is very simple. I have explained it in the previous problem. So the same formula, er into x to the power n, we have to use. Er value, it is here. We have substituted x to the power n. X to the power n is the given number. X to the power n, this is the number. Base with power 1 by 4. Use the scientific calculator and get the answer. The answer will be looking like 0.0001. Some digits will be there, but I have considered 4 places of decimal because I want to say that the absolute error in x to the power n is starting with the 4th decimal place. Therefore, we can say that the error affects the value of x to the power n from the 4th decimal place. It is starting with 1. So it is starting with the 4th decimal place. Error is having the value from the 4th decimal place. Before that, all are zeros. Therefore, the total value of x to the power n will be affected only from the 4th decimal place onwards. So therefore, the number of trustworthy figures in the given number, that is in the given number, this particular number is 3. When the answer is affected from the 4 decimal places, the number of trustworthy figures will be 3, because you please look at this value. This is x to the power, this is x to the power n. When we compute this using the calculator, the answer is going to be this much. So here how many figures are there? Here totally we are saying that the trustworthy figures is 3. Therefore 1, 2, 3. Answer is affected only from the 4th decimal place. The final answer in this number is affected from the 4th decimal place. This is the 4th decimal place. First decimal place, second decimal place, third decimal place, 4th decimal place, 5th decimal. The answer will be affected from this digit onwards. From this digit onwards. So we will not be considering these digits. We will consider only 3 decimal places, and hence the final answer of the given number will be written as this thing, that is 5.055. That is the final answer of this number which we have computed with these many decimal places, ignoring the decimal places after the 3rd place, because we are saying that the decimal places after the 4th place will be affected because the error is starting with this number. Therefore, we are keeping only the 3 decimal places in the answer, and in this way the calculation of error will help us to evaluate the given number of the form x to the power n. I hope you understand very well. Now there is a time for you to work out more and more examples using your reference book. And now I will conclude. Before going to conclude my session, I request you people to look at the questions, multiple choice questions. They are available here. Please try to answer to these questions. Please write your answers in the comment box. So these are the questions. Please have a look at them. This is the 4th one and this is 5th one. So I hope it is enough. Thank you very much. Please refer this book and try to solve more and more examples. Thank you.